All right, welcome back. Hononegah, Honors Algebra 2, Section 2.4. We're going to continue with modeling quadratic functions. Not everything is going to be perfect model of data. So when data is equally spaced inputs, you can analyze patterns in the differences of the outputs and determine what type of function we actually occur. A linear function is a constant difference. So if you actually take from one number to the next one, and if it has a common difference each time, then that would be a linear term. But if you actually get a common difference and then a common difference of the second difference, and all of them are the same, this actually makes it a quadratic function. So if you are looking at something and determining whether it was linear or quadratic, you actually would take the y values and subtract them. And if it has a common first difference, it's linear. If it has a common second difference, it's quadratic. So again, we're not going to do much of this. And in fact, a lot of times when you actually get data, it's not going to be perfect. And so this makes this question very challenging. So we're going to do this question by hand. But to be honest with you, most of the time you're going to use a graphing calculator, which I'll show you in the next example. So here we go. Let's do this by hand. A former NSA employee designs a model airplane that flies in a parabolic path. The table shows the heights of the plane's t seconds after the starting path. Write the function that models. So I don't know the vertex. I don't know the x-intercepts. And so therefore I have to use the y equals ax squared plus a bx plus c model in order to write this. So I'm going to write an equation for 3 of the points in this particular curve. So I need to find, I basically use 3 points to find an A, a B, and a C. So here we go. 19, I'm going to make it real small here. 19, and you're going to put 1 in for X. And then 20.4, and I'm going to put 2 in for X. And then 19.9, and I'm going to put 3 in for X. So now I have 3 equations with 3 unknowns. I need to get rid of one of the letters. I need to get rid of one of the letters again, and then I'll work from there. So again, this is not going to be necessarily pretty. I'm going to extend this just to give myself more space. I'm going to move this. I can't move it too far then. All right. So let's get rid of C. So I'm going to multiply the top by a -1. So if I multiply the top by -1, I'm going to get negative 19.1 equals negative A, negative B, negative C, and 20.4 equals 4A plus 2B plus C. C is gone. 3A plus B, and then that ends up being 1.3. Now I need to get rid of C again. So I'm going to multiply by -1 again. So negative 19.1, negative A, negative B, negative C. That will get rid of C again. 0.8, 8A, 2B. Now I'm going to multiply this one by -2. So I get negative 2.6, negative 6A, negative 2B. That gets rid of the B. So now I'm down to negative 1.8 equals 2A. Divide by 2, A is equal to negative 0.9. So I've got an A value. Now go back up here and put negative 0.9 in for A. So 3 times negative 0.9 is negative 2.7 plus B. That makes B equal to, if I add 2.7, B is equal to 4. And now I go all the way back up into the first one. 19.1 equals A plus B plus C. So 3.1. So I subtract 3.1 and I get 16. So my model using 3 equations is negative 0.9 x squared plus 4x plus 16. Now I can answer the question because I have a model that goes with it. Approximate the height of the model airplane after 6.5 seconds. So I'm going to put 6.5 in for x. So on my calculator, I'm going to put 6.5 squared, 6.5 plus 16. 6.5 squared times negative 0.9 plus 4 times 6.5 plus 16, and I'm going to get 3.975, and we're talking about this being in feet. Now we're going to start actually, real life data doesn't always make an exact quadratic relationship. Usually does not have a constant second difference because the data are not exactly quadratic. Relationships are approximately quadratic, have what's called a second difference that is relatively close. Many technology devices such as a graphing calculator or websites such as Desmos have quadratic regression features that you can use to model a set of data. So that's what we're going to do with this next one. So we have a table of values shows the results of an experiment testing the maximum heights of y supported by the ice in inches thick. Write a function that models the data using a graphing calculator. So now I need to pull out a graphing calculator, and I'm going to enter this data then into my graphing calculator. So let's pull up a graphing calculator so that we all have that device. Go to Stats. So click on Stat. Give me a second here. Stat. Edit. So I want to enter my data into the stats. And now I already have some information here because I used that the other day. So what do I need to do? I need to clear it. So he'll enter, or excuse me, go up to the top, hit clear and enter. And then I'm going to arrow over, arrow to the top, hit clear and enter. Don't hit delete. It will delete your list. So now take a few minutes, hit pause, and go ahead and enter your data. All right, welcome back, and you'll notice that I went ahead and took the time to enter those data, enter the data into my X and Y. So now let's change our plots, and let's change, we want to go to what's called zoom stat, and we also want to go to y equals. Let's go to the y equals first. So I'm going to go up to y equals, I'm going to arrow up to plot, and I'm going to hit enter, and then I'm going to arrow down, and it should be highlighted. So I'm not sure, enter. All right, so our plots are now highlighted. Go to zoom, and all the way down it's called zoom stat, so number 9. And what that's going to do is it's going to enter basically the dots or the points, the stat points that you had. Now, I want to create a quadratic here. So go back to stat, arrow over to calculate, and I want a quadratic regression, number 5. So the 5th option down. Depending on how old or new your calculator is, you just need to hit enter until it gets to calculate and then hit enter again. So now I am given an A, a B, and a C. So I can write an equation. There's my A, there's my B, there's my C. Now I want the calculator, so if you were going to be asked a question, give me a model, you would write y equals, I'm just going to put it here, I'm going to erase it, y equals 0.0998 x squared minus 0.4978. I usually round to 3 decimal places, x minus 5.0072. So that would be the answer if they were just asking you to write a model. Now, I'm going to erase this because I want to do another item with my calculator. I don't want to have to round. I want the calculator to be exact. So go to, and this is going to be a tricky one, go to y equals, and I want that I just wrote here, and here's how you're going to do that. This is going to be weird. Hit vars, go down to number 5, statistics, arrow to the right to equation, and hit enter on reg equation. So it's going to put that exact equation into the y equals. So now when you hit graph, it literally is going to make a quadratic that goes exactly through those points. Now, it does ask me a question. If I go back to it says, how much weight can be supported with a 22-inch thick piece of ice? So I want to go to calculate a value, and the value I want is at 22, and hit enter. And so it can support 32.35, 36 if you want to round to the nearest hundredth, pounds. Okay. That concludes section 2.4. If you have any questions, please make sure you talk to your teacher, and good luck.